Welcome to all. This is Srinivasan, Assistant Professor in Mathematics Department, C. Sairam College of Engineering. Today we will discuss Module 3 and the topic is Fourier transform. In this topic, we discussed two subtopics. One is what is the real life application of Fourier transform where we used in engineering field and based on our own problem. Okay. So before going the application, first we discussed what is meant by Fourier transform. Who is the Fourier? Okay. So this is the Fourier history. The Fourier transform is invented by a French mathematician. His name is Jean-Baptiste Joseph Fourier. So his name is Fourier. He found the formula for the transform. That name is the Fourier transform. And also he found one series. That name is Fourier series. Okay. So he also a mathematician and also a physics and historian too. Okay, and is and his early ages he joined an army to educate the scientific section for the corps. Okay. After that he resigned the job and he started to in the mathematics field. Okay. So what's the application of Fourier transform and where we used it? Okay. In the application of Fourier transform we used in the following field. One is signal processing, another one is image processing and heat distribution mapping. In the signal processing for EC and triple E field, we used the signal process. Imaging process is the film industry, and heat distribution mapping is we used in the mechanical field. Okay, and wave simplification, light simplification, and also radiant measurement of etc. How to use this one? Okay, the next one. See, what is mean by transform? A transform is nothing. We can changing from one variable to another variable. That means we can convert to time to frequency. See the first diagram. Can convert time to frequency. We will get some length. It's a sine curve or cos curve. So we get some equation. That equation we solved by the Fourier transform. After that, it convert to okay, can convert to some length. See the if you for piano, if you take piano in the first wave, we get the small wave. Okay, the distance is small, and the last one, the frequency is here higher than the frequency of here. The first one is small waves, and here the frequency is higher. It's not only piano for all string equipment. If you music equipment, string equipment, okay, it will get the sound lower, higher. Everything is time to convert to frequency. Okay, so every frequency is a convert to sine and cosine curve. For example, see come to the here the image, the time is travel to only the straight line. After applying Fourier transform, it will convert to frequency. Okay, it will convert the proper frequency and improper frequencies. Some improper frequency we can apply the Fourier transform. It convert to proper frequency. Okay, for the diagram 2, this is the improper frequency and apply transform. I get the proper frequency. Okay, the Fourier transform application we can convert to time to frequency in the normal way. So for signals also we can convert to time to frequency, and also that wavelength. Every wavelength is some frequencies there. The time we can convert to normal for frequency. Okay. Now we discussed one based on problem. Self-reciprocal function. A function f of x is said to be a self-reciprocal under Fourier transform if capital F of x into capital F of small f of x equal f of s. So f self-reciprocal is nothing x to s. It is a self-reciprocal. So now we discuss the one problem. Find the Fourier transform of e power minus a square x square and hence deduce that e power minus x square by 2 is a self-reciprocal under the Fourier transform, or show that e power minus x square by 2 is a self-reciprocal under the Fourier transform. So self-reciprocal is nothing, we can convert to x to s. Okay. Time to frequency, that is the self reciprocal. So we can convert to x by s. The final e power minus s is, if the equation final we get e power minus s square by 2 means yes, the equation is self reciprocal. Otherwise, it's not self reciprocal. We will check it is self reciprocal or not. So given the function e power minus a square into x square. Okay. So Find then apply Fourier transform. So f into f of x equal to 1 divided by root 2 pi into minus into plus infinity f of x e power isx into dx. Now substitute the function. What is your function? Into e power minus a square x square. Now substitute e power minus a square x square. So here I take e power minus a square x square and one more term is e power isx. So e power minus taking outside we get a square x square minus isx into dx. Now this equation I compare to a minus b the whole square formula. I take this one is a square and this one is minus 2ab. What is a minus b whole square? That is a square minus 2ab plus b square. I consider this is a and this is minus 2ab. Okay. So the formula of here I take a equal to ax and 2ab equal to isx. So by using this one find b value, b equal to isx divided by 2a from this equation. So isx divided by 2 into what is ax. So clearly x and x are cancelled. We get is divided by 2a. So this is b. So a square minus 2ab equal to a minus b whole square plus b square. Now replace ax whole square minus isx by this term. So here I substitute a square x square minus isx replace a square minus 2ab equal to a minus b whole square plus b square. Okay. So a minus b whole square plus b square. Here b equal to s by 2a. Okay, I square is minus 1. So minus minus plus s square divided by 4a square. Like this one. A square minus 2ab equal to a minus b whole square minus b square. Now, which one is constant? Here clearly we know s square divided by 4a square is constant. So I multiply e inside and I split the two terms. We get one is ax minus is divided by 2a whole square. Another one is e minus s square divided by 4. So clearly this is a constant taking outside. We get interval in minus into plus infinity e power minus ax is divided by 2a the whole square into dx. Now I take this is t. So t because I can't integrate this entire term the normal procedure. So I will take this t. So t equal to ax minus is divided by 2a. Then dt equal to a into dx. This is constant. Now substitute this value in the previous equation. We get integral minus into plus infinity e power minus t square dx value is dt divided by a. Here also a is constant. Taking outside we get integral minus into plus infinity e power minus t square into dt. Clearly this value is root pi. Interval 0 to infinity e power minus t square into dt value is root pi. Now substitute this value replaced by root pi, we get this one. So e power minus s square by 4a square divided by a into root 2 pi. This is root 2 pi can be written as root 2 into root pi. So this root pi and this root pi cancel, we get root 2 only. So e power minus s square divided by 4a square divided by a into root 2. Okay. Now substitute a equal to 1 by root 2. Why I substitute a equal to 1 by root 2? Our aim is to find to prove e power minus x square by 2 is a self reciprocal. So I don't want the a. So substitute x equal to root 2 e power minus s square divided by 4 into 1 by 2. So a square I substitute here a equal to 1 by root 2. Okay. So a equal to 1 by root 2, a square equal to 1 by 2. So this 2 times cancel, we get e power minus s square by 2 divided by a equal to 1 by root 2 into root 2. So this root 2 and this root 2 is cancelled. We get e power minus s square by 2. So here put a equal to 1 by root 2. We get e power minus s square. So f of e power minus x square by 2 equal e power minus s square by 2. So therefore e power minus x square by 2 is a self reciprocal under the Fourier transform. Why? The function is x, I convert to s. So time x2 I convert to s. So time to frequency I converted, everything equal only. Okay. So what is the transform? Changing from one variable to another variable, the form is different but the values are equal. That is meaning the transform. So clearly this is Fourier transform is self-reciprocal. So thanks to all. I hope you all understand this video. Okay, thanks for watching.